Well, welcome back. So, last time I left you with a cliffhanger of how do we use multiple correlation when we can't observe the actual observation of our construct. Well, let me tell you. With factor analysis! Yeah! I don't know how well this enthusiasm is conveying as a fish. Ooh. Wah, wah. Well, whatever. My goal is to keep us all sane. So, what is factor analysis? So, factor analysis, which I'm going to abbreviate as FA because it's a mouthful, and PCA, which is principal components analysis. These are different, and well, there's a hot debate among scholars on how these two relate. Uh, but I'm including principal components here because I think it should be talked about as well. And both these techniques are methods of data reduction. The idea is to take many variables and explain them with as few factors or components as possible. And the idea is that correlated variables are grouped together and separated from other variables with low to no correlation. All right, so factor analysis and PCA both help us identify patterns of correlations. And PCA is more of a descriptive approach where its goal is not to identify the underlying structure, but merely optimize the efficiency of how it compresses the data. Its goal is to get as few components as possible to explain the majority of the variance in the space. Versus factor analysis, which tries to explain the underlying relationships. So, if you recall from those diagrams way back when, factor analysis is trying to identify how those individual items relate to that overarching thing. PCA doesn't really care. It just wants to reduce. But anyway, so factor analysis is a process of providing an operational definition to a latent construct through a regression-like equation. Now, there's a lot more to this that I often grapple with how to explain given just the wide range of stats backgrounds and math backgrounds that there are in this class. So please talk to me if it's too technical. I apologize and will be happy to help. It's just this is the challenge of online teaching. It's engaging that. Alright, so we can kind of break down factor analysis and kind of these dimension reduction techniques into principal components, so PCA, and common factor analysis. There are two subdomains of factor analysis that I'll talk a little about more so that you know that they exist rather than go into the nuances of how they are different. But this is kind of the broad structure that we're going to use for these for these methods, just to help keep everything on straight. All right, so here are the general steps for a factor analysis. So first, you want to select and measure a set of items in a given domain. All right, so that's step one. So that's picking your questions, developing your questions, getting your data. And next, you data screen in order to prepare your correlation matrix. So this is where you clean up your data, you reorganize it however you need to, and then you extract your factors. All right, you probably can't see my like discomforted fish face, or because I'm behind a fish, but this is the general approach that people tend to take. I have strong opinions that this is not a great technique, but it is what people do. So yeah, so then you extract your factors and you rotate them to increase your ease of interpretation. Then you interpret them, and 6, you further validate your measures and do additional studies. All right, so factor analysis questions. So it has 3 general goals within the context of psychometrics and psychological testing. 1, data reduction. 2, describing relationships amongst the items as well as the higher order latent constructs. And third, it tests theories about those relationships. We'll talk a little more about this, but unfortunately I can't go too into depth, just because this is an undergrad course. But there's a lot of cool things you can do with evaluating how factor structures work and test different relationships and see which model explains your data best. I will be back because I need to rescue my pizza. So, more factor analysis questions. How many interpretable factors exist in the data? Or how many factors are needed to summarize the pattern of correlations? What does each factor mean? How do we interpret it? What is the percentage of variance in the data accounted for by the factors? Other questions that are good to ask ourselves is, which factors account for the most variance? In other words, which component of our test explains the bulk of the variability in test performance? Now, how well does the factor structure fit a given theory? Does the data look like theory would suggest? Because often data do not look like the theory. And when we have data that do not resemble the hypothesized factor structure, well, that leads to a lot of big questions. And often you can see that by looking at how well the model fits. And I'll talk maybe a little about that. I haven't really decided yet. And last, what would each subject score be if they could be measured directly on the factors? Now, there are techniques to extract factor scores. They have some serious limitations, but it is common practice to estimate scores as a function of the individual items from the factor loadings. All right, so here are the kind of 2 types of factor analysis that we're going to talk about. One is exploratory, and the idea here is that you are summarizing your data by grouping correlated variables. And when I say variables, I mean test questions. The idea is to see and explore what the data look like without imposing a preordained structure. That's the other type of factor analysis. So here we're investigating the sets of measured variables related to theoretical constructs. And this is usually done near the onset of research. And we are going to primarily talk about this type in this video series. But my favorite technique, the one that I live and breathe, the one that is beyond the scope of this course, is confirmatory factor analysis. It's a more advanced technique. It allows you to evaluate those discrepancies between a known factor structure that you've imposed, or at least hypothesized, on your data. And it allows us to evaluate how good of our theory is at explaining our data, or how good our data is at explaining our theory, if that makes sense. And this method is often tested through structure equation modeling methods. And again, unfortunately, this is well beyond the scope of the course. But it's really cool, and I really wish we could talk about it more. But we're going to focus on exploratory factor analysis because it's easier to do, frankly. And I just don't think that I can do a, well, I don't want to say I can't do a good job, but I think that it would be really challenging to get everyone up to speed with factor analysis if we do the more fancy stuff. But anyway, thanks for watching the weird floating fish that is Mason. I will see you in a bit. Bye! I don't know why I'm waving because you can't see me.